Hello, everyone. I'm Dr. Tina Burns, and welcome to Lecture 2D, which is the fourth lecture in our Week 2 module. So let's look at a roadmap of what we're going to be going over today. We're going to review structs or structures. We're going to discuss unions, and then we're also going to go over typedefs or type definitions. Now, keep in mind that a structure is a collection of data items, and it's really good for helping us to organize data. Now, this can consist of elements of different types, and it's a good way to just organize data. Here's a general format for a structure. You have your variable type, then the name, brackets, and inside of the brackets, you are indicating what you want to set that up as. You also want to make sure that you end this with a semicolon. So let's go ahead and do an example of one here. Let me make a folder for this. So this is our standard folder for our test for our lecture. So we're gonna go ahead and make a directory for week 2D. We're gonna copy week 2A, the make file for that, into week 2D. And then we're gonna go into 2D, and that's where we kind of start. All right. So let's clear our screen here. I'm going to go ahead and open that make file that we just created. So that we can become better acquainted with it. All right, this is one of the programs that we kind of left off on before. Now I'm going to start this by just doing a very simple creation of a structure. Of course, we are in C, so we're going to make sure that we include our libraries. Oh, let me save this file first as a C file so I can kind of see the save this as a C file so that I can see the information here. All right, now this is a C file. Our comment is going to be include libraries. Right, we already know that that's kind of always where we start off here. Include standard input output. We're also going to include our standard library information. Here's where we're going to declare our setup structure. I'm just going to leave space for that. And here, of course, is going to be our main function. All right, and what I'm going to do is a very quick check here. So this is a structure test. Okay. All right, now that we have all of that there, we're going to save this. We're going to go to our make file and change this to structure test. Save it, make it, and we're just verifying that this actually output the information, and it did. All right, so now that we're there, let's go ahead and start working with this. I know I'm going to have something at the top here that allows me to print the data. This is going to allow me to access the data. All right, so I'm going to set this up. Let's use the same format that we used before, which was kind of the student, this student structure item here. All right, so this is where we access our data. So we already know that our struct is going to have this type of format. We're going to set it up with the name student. We know we're going to have a beginning brace, end brace, and we're going to end it with a semicolon. So let's do our name. We'll make the name just a chart of characters. We're going to make the ID an integer, and we're going to make the GPA a floating point value, all right? So that's just setting up the range for our structure. Now, if you remember from the previous slide, our 3 steps for performing this action is to set up the structure, to define your variable inside your function, and then to access data within that particular structure. So we've set it up. Now we're going to set up a variable here in our function in order to access the data. So our variable, we're going to call the student Alice. All right. Boom. Now we have set. Now I have to remember that I need to tell what type of data this is. So I'm going to say struct student is Alice. Now, in order to access that, we already know that's pretty simple. It's going to be right. And we kind of already remember this from the previous class. All right, and then we'll do something for the ID. We'll make that 304 or something along those lines. And then we're going to do something for the GPA, student 98.5. All right, so this is the GPA. Now, in order to print this data, I'm going to use that same printf function. All right, all we're doing is just kind of setting this up. We always know that in order to print our data or to substitute the information here, it's going to be kind of this %S. We're going to follow that up with a new line character, and the data we're putting in here is alice.name. All right, that is done for that, for printing out the data. Okay, now we have here, we're going to have the ID, and here we're going to have the GPA, all right? It's going to be ID. All right, so now here's all of our information here. Question is, did it compile? Does it compile? All right, we got one. Oh, we got a few errors here because I did not change that. This is going to be an integer, so that's going to be %D. This is going to be a floating point value, so that's going to be F. Very simple changes there. Oh, and our ID and identifier here is actually lowercase. So let's make that change. All right, we have made that change, and we can go ahead and run this file, and it indeed prints out our information. Now, if you notice that this is kind of our setup for structure, we're going to go into something that's super similar, and what this is called is a union, all right? So structures, just as I talked about before, we have a character array here. We have a integer value for our ID, and then we have our floating point value all in one data structure. So that's kind of where that goes into. We're accessing this with a dot because this is not a pointer. It is just the actual data, which is why we're accessing it with the dot notation. All right. And that was information kind of from the previous slide, from the previous class. All right. So now let's go a little bit further. Unions are very similar to structures. They're just they are a data structure, and they allow you to store different types of data. What's unique about them, or what separates them from structures, is that they store it in one memory location. That means that only one member can be accessed for the data at a time. So you can't access multiple members. It's just one by one, all right? And this is a beneficial data type because it helps us to save memory when multiple values are being used simultaneously. So for example, let's say I have a book, a phone book, and I don't really look at that often, but I want to maybe get a name from it. This might be something you would use because you don't need to get multiple information. You're just going to access this periodically to get that one particular item. Let's look at an example of a union and see. We can have something like this that kind of shows how these unions are set up. And if you'll notice, right, it's very similar to our structure format. It's super similar, right? Where you're going to have the type, you're going to have the variable, and then you're going to have the different sets of data that you're including this. So one would think that I could just kind of take what we had here. We're going to save this, and we're going to update this for union. We're going to update our make file to also indicate that we are looking at unions. All right, so we've saved that. All I did here was I just said, hey, instead of you being a struct, I'm going to make you a union. Yay, you're a union. The data and everything in here basically remain the same. All right. So now I have this information here. Let's see what happens when I make the file and execute it. My first issue is that I did not update that guy. All right, I was able to successfully make this, right? All right. Now we're coming upon the error that I was expecting. You'll notice that this says, hey, there is some sort of memory leak here. Not sure what to do about that. So remember I was saying that for unions, it can only access one element at a time. So the first thing it looks at is kind of like this Alice name, and it has a memory address for that, which means it's always going to be looking for that data type. It's always going to be looking for that particular information. And when I try to get the ID from this union, what happens is that it tries to overwrite data that is currently in this memory address. So it comes up with a memory leak because for this structure, you can only access one element at a time. So for this purpose, we can actually get rid of this. And you'll see that it will print out just for one. And there we go. That's where it prints out the one data, right? So keep that in mind that as you're dealing with unions, you're only going to gain or attain access from one type of one element at a time. Whereas a structure, as we saw from the previous example, you can get multiple things from that structure or access multiple elements within that um, data structure. All right, now what I want to do is allows us to still access the different components of this union without creating an error code. So the first thing we're going to do is, as I've stated before, you're going to access one member at a time. And it's typically going to keep the data format of the largest item, whatever that item is. And in this case, it's going to be the string character that we have here. All right, but Uh, I could do something like this where I say, hey, let me print out the data here. So I want to access this one. And then the next thing I want to do is I want to find out a way that I can access that next member. So then let's say I'll make the ID. I'm going to go ahead and make this ID a floating point variable. So before I do anything else, what I want to do is just make sure that I can run this successfully, right? And it did in fact run it without error. So now the next portion of it is let's see if I can then print out this ID information, right? Now I'm doing this intentionally step by step so that we can see kind of the process and what happens as we get these different elements here, right? So now I'm going to print this out. I'm going to print out my ID information for the actual student. Let's save this. And now you'll see it will run. It'll go ahead and say, this is what I'm doing for this portion of it. This is what I'm doing for the ID. And conversely, you could do the same thing for the floating point and for the GPA portion here. The difference is that why this is so important is because unlike my structure where I can just have them all in a row and then access them differently, I now have to do this piece by piece in order to access the data, right? So you notice that before when we went through and we ran it, we tried to set all of them at once, and then we tried to print out the data. Uh, and when we ran the print function, because it's accessing the same memory file, that print function was trying to print out the ID when the format of it was actually a string because that was the previously stored data in that particular item. So if we wanted to access or get the data for each one, you have to deal with every item separately. All right. So now we can get the data, but we're dealing with each member on its own. That means do whatever you need to do for this member, finish it, then move to the next member. It does not retain the data from the old member, right? So then if I ran this again, let's go ahead and make this. And now you'll see that, okay, yes, it does print out all the information, right? So again, what does this look like realistically if we were to say, right now I'm going ahead and I'm accessing each member differently. Access GPA data member. I am not accessing the whole. This is going to be GPA. This is going to be my ID. Now let's take a look at it just one instance further. And let's see what happens when we access. If I wanted to print out, let's see what happens when we try to assign different numbers to those and then access that data. So let's go ahead and play around with the different data accesses. Let's go ahead and now we're gonna set up Alice ID equal to 15. And now um let's print the data afterwards. That right? Print. Okay, so this is after reaccessing the information or ID. And we'll go ahead, since we've made this an integer, we can make that %d, and we'll go ahead and enter that. And of course, this is going to be data or Alice.id. All right. Well, let's see if we can make this successfully. All right. Let me go ahead and make this lowercase here. We'll set up this guy to properly access that data point here. All right, and so now we've accessed that, and it will print out the information for our ID. Now, what happens if we further access this data? Now, I have accessed this. I've set this to something else. I'm now going to set my name to something different here. Let's print out the name. I'm going to kind of copy the same data here. After second access. Okay. All right, so this is my name after I did the second access. And then what I want to do is I want to see what happens to my ID after I have accessed the previous member. All right, so what am I doing here? So and I'm not even going to print that. I'm going to actually store that here. Let's see if I can make this first before we go on. Let's run this. Okay, now I have my data. This is after doing the GPA. Let me put a couple of extra lines here because I want us to see kind of what we get when we have this trash value here, right? This is now I've reset the ID. I've accessed it. This is going to be the name after you've reset it here. Now what happens to my ID value once I have finished with the data there? You'll notice that it has this trash value here. It's trying to get information from this, but it can't. I originally stored 15 here, but it's not going to have 15 because now it's looking at the information that was just accessed previously, which is now part of my name function. And that's the point I'm trying to stress here is that once you have accessed a different member, this is what the previous member is now going to be looking for. Let's do one more example so we can kind of further see that. Let's set up our GPA. I'm going to cheat and just kind of copy this GPA down here. All right. GPA. Now we'll set that and let's make this just so we can see it. We'll make it 80.5. And then let's look at what happens to the name after we try to access that. So as we make this guy, now notice that this is going to give us an error because we are now trying to access the data after we have kind of changed the data type. So if I'm going to go ahead and comment that out, right? I can access it fine here. I have my GPA. I can access the ID. Now the ID is going to have this weird number because again, it now notice how it changed from when we previously printed it because now it's expecting the same data that it had before once it's rewrote the name value. Now when I go in and I try to update this GPA portion, this is just not very happy. And the reason that it's not happy is because, again, I'm trying to change another member inside of this and then um, gain access to that data. Okay, so what is the point of all this? Point of all this is that when you're using unions, keep in mind that you want to access and have the information for just one particular item at a time. All right. All right, so that takes care of unions. Let's go back to our slides and we'll talk about the other element here. Or let's talk about kind of the similarities between structures and unions. Both of them are going to store multiple types of data. And for this data, it can be passed to and from function to function. And it also allows access to the members. What that means is that I can change the information or the data. I can update and modify the data with inside that um that data structure. Now, when we look at structs, strut versus union, for a strut, the data is stored in various memory locations. And that does mean that you are going to consume a lot more memory. For the union, the data is stored in one memory location, which means you're going to have less memory. You can kind of save a little bit of space, and that's why in some instances you might prefer this in order to maximize your computer usage. For a struct, you're going to have multiple members that you can access. For a union, as we just saw, you can only get to one member at a time. You cannot try to do multiple members, but it's just one at a time. And finally, for a struct, it's going to have data members that are already initialized, typically going to be at nulls, but they're going to be already initialized to some value. And for a union, those members are actually going to be uninitialized. All right, and let's go over our final element or item for today, and that is typedefs. Now, a typedef, it's just a keyword that is used to create new names for existing data types. You can think of it like a variable name or a nickname. It makes your code a lot more readable, and it helps you to scale it up and maintain uh, your names and your variables throughout and across multiple functions. It's used a lot with structs and unions because if I do this, then I don't have to declare struct or a union each time. But it also might be beneficial for something like long integer or short integer, so you don't have to type two words in order to define that data type inside of your function. Now, it's going to help you simplify some complex type definitions. So let's look at an example and kind of a setup here. You're always going to set it up just like this, right? You're going to have your uh, type, your data struct, your data type, then the name of the type, and then the variable name. So what does that look like? Here's one example. If you were to use this kind of unsigned integer example here, you would have, this is your typedef, that's always going to go before it. And then you have your type of variable, and then your variable name. So let's kind of go ahead and look at this in our code. I'm going to steal this code here. Save this as typedef test. Update our make file to be typedef. All right, now we're going to start off really, really very simple. All right, I'm going to get all this out of here because I don't actually want to use that right now. And what I'm declaring is a typedef. And let's make this a long load. No, actually, let's make this a long integer. Long integer. All right, so the first thing I did was, all I did was say, hey, I want to make this some sort of long integer and get the data there. All right, now when I get to this portion, if I wanted to declare something here in this bottom function, let's say I want to make a my int, I don't have to declare this as a long integer anymore. I can just use the name that's here. Was equal to, all right, we'll set that up as our long integer value. And we'll make the long integer, we're just gonna call that x, all right? And then of course, if you want to print this out, I believe LU is the right notation for this. We will find out very shortly. And then all I'm going to do is just print this out. What I'm setting this up as is X. So I should be able to make this file. And it run. Well, this is still doing our union test. Let's set this up as type definition. Well, one problem is I actually spelled this wrong. So we're just going to go with that file for now. And we were able to successfully make this. So let's go ahead and run this program. All right, and you'll see that, hey, it did in fact print out what we were anticipating for a type definition. Now, that was one way and one example to do that. Relatively simple, but you may be asking yourself, why the heck would I want to do that? It seems like a lot of extra work. So what is the point? What is the benefit? Well, this is one example using the long integer, but a lot of times what we see this used for is the structure and unions. So let's go ahead and use this one for a union. I'm actually going to start with, rather than a union, let's go back to our structure. Um, we actually are going to save this with the right name this time because uh, so we're going to save this here. All right. So what do we see here? Um, this is our original code, and the only thing I'm going to do here that's going to be a little bit different is I'm going to set this up as a type def. Looks the same. Um, Now I'm going to do something that's a little bit, well, I'm not going to do it yet. That means when I declare it here, I do not need to have the name here. So imagine this whole thing right here is your variable, like your variable name, right? That means the type def is going to be needs to have a name. So I'm going to show you guys what I mean. So I'm going to execute this, but it's actually going to come up with an error. All right. Came up with a bunch of errors because it is expecting this to be a structure, but it's not. It needs to be a type def, right? So question is, how do we fix it? Well, all we need to do is give this an actual name. So here's what's happening here. This entire section, just give me a minute while I work out some annotations. Sorry about that. I'm going to work out some annotations. This right here is my variable height. This then is going to be my variable name. All right. So now that I've named it, what I can do is I can go back and now run this as the correct nomenclature for my item. And you'll see it got rid of all those errors. So again, just so that's clear, this whole structure thing right here, this is all just my variable type. After I have my variable type, right, just like it said in our slides, once you have the variable type, when you're finished, you're gonna have to give it a name, right? So we need to have the name according to the type def. All right, and in our example, our name that we're using here is uppercase student. And your name is always going to be at the end. If you're running this on a structure or a union, your name is going to be at the end, right after the bracket and before the semicolon. All right, so now we've seen that I can successfully make this type def. I can call upon this, and I can use that in my data. And you kind of see this as an example if we wanted to use union. Very similar thing, except for this one, we're doing it by union. And this is indeed how we would call that data out. Notice that I do not need to declare this as a union because it's already established with that type def. All right, and that's pretty much it for today. We might go over a little bit more of unions and some examples in the next few weeks. But for now, please enjoy the rest of your day.